Cash forecasting is a critical function of the treasury department in any company. By its time horizon, it can be divided into short-term and long-term forecast. The short-term forecasting aims for cash balance in the next few days or a few weeks for funding purpose. The long-term forecast typically has a 6 months or even longer horizon, and it is for capital planning purpose. A good short-term cash forecast enables precise decisions regarding borrowing from the revolver facility by accurately identifying the exact amount and timing of funding needs. This precision minimizes unnecessary borrowing, reducing the principal on which interest accrues, and ensures that funds are accessed only when required. In a high interest rate environment, this ability becomes particularly valuable as it directly lowers interest costs, preserving liquidity and optimizing financial performance. Today, we are going to discuss the short-term forecast with some ideas from AI, specifically the underlying concept of large language model, LLM. Not known to many, short-term cash forecast is often one of the most challenging tasks. There are a few challenges. Let me start with issue with lack of high-quality historical data on daily cash receipts and disbursements. One must know the history in order to forecast. Many companies, due to fragmented data collection systems, inconsistent SWIFT message, or broken manual processes, have low-quality historical cash data to start with. Although most of the time the ending daily balances were accurate, as they should be, the categorization can be off. For example, payroll is booked as normal disbursement, or proceeds from revolver payment is booked as intercompany transaction, etc. This low quality of data graduality can hamper predictability down the road. Secondly, there are companies do use certain type of regression tools or alike, but they oftentimes end up with a barely acceptable result. Regression models and math-based models often fail in cash forecasting for several reasons. First, tools like Excel offer limited functionality for building robust regression models, lacking the flexibility needed for complex cash flow patterns. Second, math-based models rely on explicit equations that assume stable relationships between variables, which may not adapt well to the dynamic, unpredictable nature of real business environments. Third, these models come with a steep learning curve, making them challenging for treasury analysts who typically manage forecasting but may not have advanced mathematical or statistical expertise. This mismatch limits the practicality and effectiveness of such approaches. Last but not least, and it is from my first-hand experience, many people lack confidence in using historical data and statistics for cash forecasting, yet they often unknowingly rely on methods like averaging past days or months' cash balances, essentially a statistical approach. This contradiction arises from a distrust in formalized processes and a preference for intuitive methods shaped by psychological biases. Such informal practices lack consistency and scientific rigor, leading to errors and inefficiencies. I myself was stuck in these challenges one way or another in the past years. Just recently, I accidentally learned some underlying concept of ChatGPT, and it started to shed some light on this topic. There are various ChatGPT products in today's AI market. Most of them, if not all, use the same technology, large language models in short, LLM. Large language models predict and organize responses by analyzing human input and generating text based on probabilistic patterns in language. They use tokens, which are smaller units like words or subwords, as building blocks for constructing response in human language. An one-token response is an output from a language model that consists of only one word. An example is if the input is, "What is 2 plus 2?" A one-token response might simply be 4. LLMs also use the concept of n-grams, which predict the next word based on the preceding words. N-grams are useful for building models that predict the next word in a sequence. For example, the machine is asked by human to predict the next word to complete the sentence. In a 2-gram model, the machine predicts the next word based on like, and a 3-gram model predicts based on I like. The likelihood of producing a complete answer such as I like coffee is higher than just analyzing like. This context awareness allows LLMs to generate coherent, relevant responses. This seems as a paradox that ChatGPT doesn't know how to talk, but with these kinds of algorithm and enough training, it can predict word by word as if it is talking. Its implication to cash forecast is that we need break our mental cage and embrace the same methods. Predicting the next day's cash balance is no different to an one-token response. Plus, if you get the past 4 days' actual cash data and add them together with the next day forecast to check if the group of 5 days makes sense, you are doing 5-gram model. Many of us have already used similar method but fail to articulate, therefore not confident enough to assert it is a winnable path. If ChatGPT can succeed, cash forecast certainly will. Now, I would like to illustrate how to build a cash forecast model adopting these two concepts. As I'm limited by tools available, it is just a demonstration. In this imaginary company that I created, it managed to preserve 1-year daily cash balance, recipients and disbursements data. That includes AR collection, AP disbursement, payroll, payroll tax, and tax payment. Unfortunately, this level of data was polluted, therefore the breakout is not reliable. What we do trust is the net cash from operating activities, which is the total of the 5 above. There are a few other categories of cash activities, such as external bank loan, intercompany cash movement, and cash payment for share repurchases. Although these items affect total cash balance, they should be planned, not forecasted, therefore are excluded from forecasting. To give this company a bit more lively color, I assume it has payment run every workday. It makes payroll and payroll tax every other Thursday. It typically has strong sales in the second quarter, therefore the AR collection in May, June and July is higher than other months. It makes less AP payment close to quarter end. For every workday in the past and days in the future, I created a few tags to describe their features. For example, for October 30th, 2024, I assigned number 10 for tag 1, 23 for tag 2, and 45 for tag 3. Because it is in the 10th month, the 22nd workdays in that month, and 45 workdays away from quarter end. In addition, it is not a payroll day, therefore 0 is assigned for tag 4. In forecasting the net cash from operating activities for October 31st, 2024, this model takes the daily average of trailing 12 months as input 1, the daily average of October as input 2, the average of all 23rd workday in a month as input 3, and the 45th workday away from a quarter end as input 4. All these rules out payroll days. Now it comes to the step to assign weights for those inputs. For simplicity, I assigned evenly. In real life, they are unlikely to be even. Input 4 has 0 weight because it is far away from quarter, therefore not considered as impactful. The estimated operating cash on October 31st is $103,922. The next step is to perform 5-gram model, which is adding the preceding 4 days actuals and the new day forecast. The total number is 578,867. Meanwhile, if we apply the same algorithm determined earlier to forecast the 5 days in aggregate, it is 610,568. The difference is only 31,700, about 5%. That tells the forecast of 103,922 is reasonable. Please note, for easy understanding, this model is much simplified. In real AI application, there are at least 2 levels of difference. First, the set of weighting factors are machine learned from repetitive forecast cycles and therefore self-adapting. Second, the set of factors also can be machine learned and likely to have complex implication discovered by more advanced AI technology. A story to close today's conversation. Years ago, I was requested to quickly develop a cash forecast model. The company's data quality was very poor, and doing regression would make the Excel-based model clumsy. I thought it over and eventually created a shortcut method similar to the example model. It didn't win my boss's trust. Instead, people met each morning to brainstorm what the cash balance would be in 3 days, and if it is necessary to call the bank before 11 a.m. to draw revolver. I wish I had the AI lingo to be more persuasive at that time. Thank you for watching this video. More treasury-related material will be coming soon.